My name is Mr. Olajide, and today we'll be introducing ourselves to physics. Now, before we move deeper into physics, we have to understand physics as a science and the definition of physics. Because physics is the branch of science concerned with the nature and properties of matter and energy. That is, physics is a pure science which is concerned with the nature and the properties of matter and energy. So, um, physics is more interested in matter and energy with respect to its measurement. Let's add that. That is, we can also add, in other words, physics deals with the study of matter and energy and the relationship between them. That is matter and energy. So you can say that both matter and energy, they both move together when we're talking about physics. And we can say that I wrote out the fields, some fields we have lots of fields which we cannot mention all. We have the heat, the light, force, magnetism, mechanism, inertia, gravity, sound, electricity, atoms, waves, etc. All these are what are embedded in physics, in which we are going to study all this by God's grace, but it is a step by step, and um, very soon you'll see that all these are very, very interesting aspect of physics, which everyone will be able to know. So today we'll also be discussing about the unit and measurement. What do we mean by unit and what do we mean by measurement in physics? So unit and measurement. Now, a unit or standard of measurement should be such that is, when we talk about unit, what do we mean by unit and what do we mean by measurement? Measurement is something that we can never throw away, or um, we can not overemphasize in physics. We cannot do without measurement in physics. That's why you say that most questions on physics will be based on measurement. That is, when you're talking about the speed, the velocity, distance, displacement, the amount of heat, the amount of electricity. So all this, when you are dealing more with what quantity and measurement in physics. So we are not going to talk about the primitive understanding of unit and measurement. Now, we say a unit or standard of measurement should be such that is, when we are to measure, that is to give a standard measurement of any quantity. When we are talking about quantity in physics, quantity can either be a speed, velocity, length, distance, or any other thing that we are interested in. That is, when we have to have a standard. A unit is a standard form of measurement. That is the smallest, the basic thing. For instance, when we say a unit is that small thing you can use as to quantify a matter. So a unit of standard measurement should be such that the first one, it must be possible to define unambiguously. That is, it must be possible to define it unambiguously. In our dictionary meaning of unambiguous, that is, it should not be something that we cannot clarify or we cannot understand. That is, it should be, for instance, length. We know that the unit of length is meter. There is nothing that makes it difficult to understand. So that's the meaning of the statement, that it must be possible to define it unambiguously. Now the second one, it is easily reproducible. That is, we must be able to reproduce it in as much that we are using it in calculations or we are using it in elementary definitions. It must be easily to be what? Reproducible. So the third one, it does not vary with time and place. That is, you must not say because of time factor, then we cannot use this unit at this point. And that is, the same unit you are using in Nigeria must be this exact unit you are using in Canada, California, US, or any part of the world. So it must not be something that we are going to be that will be inversely with time and place, or that is, it must be 100% constant when we are saying talking of unit. Now the fourth one, it should be possible to multiply or divide each one of the standard. That is, when we are multiplying the unit, it must be able to be multiplyable, and it must be able to be divisible. That is, for instance, when we are talking about acceleration, which is the rate of change in velocity per time, we should be able to what? Divide if necessarily, that is, and get a more derived unit if possible. Now we have two major type of major unit in physics. We have the fundamental unit and we have the derived unit. Now, when we say the fundamental unit are basic unit, and when we say basic unit, we mean unit that can stand on its own, that does not require any other unit as a support. And we have the derived unit. Derived unit are those units which are deduced from the fundamental unit. That is, we bring out unit from the fundamental unit, which are the basic unit, and we deduce it to get a derived unit. Now, the three most basic quantities in physics are: we have length. Length, most basic quantity in physics, we have the length, we have the mass, and we have the time. The length, the mass, and the time. Now, let us define what length is. Length is the extent of space or distance extended. That is the extent at which we have a space. So the extent of space is what we call length, or distance that is extended. That's length. Now we have mass. Mass means the quantity of matter or material substance. That is the quantity of matter present in a matter. The quantity of matter present in a material or a substance is what we call mass. And we have the time. Time is the difference in which events are distinguishable with reference to before or after. That is, you are placing an event. Is it happening before or after? That is what we call time. Those are what we call the um, fundamental. Those are the most basic fundamental units in physics. Now, example of fundamental quantities and units. Examples: we have the length, which is measured in meters and represented by m. We have the time, which is measured in seconds, usually represented by s. We have the mass, which is represented in kilogram, and most times represented by kg. We have lot of like temperature, which is either Celsius or Kelvin, depending on the unit we have. So we have it is usually written in degrees Celsius or Kelvin. Now, all these are examples of fundamental unit, that is basic unit. They stand on their own. But when we talk about derived units, derived units are those units which are gotten, that is the sum of two or more fundamental units are what we call derived unit. Example of derived unit, we have the acceleration. Now, when we say acceleration is the rate of change in velocity per time. That is, acceleration is rate of change in velocity per time. Now, we know that velocity, or let's assume we don't know, velocity equals displacement per time. Now, how do we so okay, let's say velocity. The unit of velocity, since the displacement is also like distance in a specified direction, we say displacement is measured in meter and time is measured in what? Seconds. So we say velocity equals meters per seconds. Now, for moving back to this acceleration, since we already have the unit of um, velocity as meter per seconds, and we all know that time, which is a fundamental unit, a fundamental quantity, and its unit is what? Seconds. Then we can now use this and this to deduce the unit of acceleration. So we say acceleration, the unit of velocity. Velocity here is meter per seconds, that is meter over seconds. Now we have the unit of time here, which is seconds, that is divided. You can see divided by seconds. Now we can now apply our mathematics here, in which division to change to multiplication. We are going to have meter per seconds multiplied by 1 over s. So we are going to have meter times 1 over second square. So our unit of acceleration is meter per second square. We can also have that of speed. Speed is distance over time. So which means our unit for speed will be equals to meter over seconds. So which is meter per second. So that is that on speed, derived unit and fundamental unit. By God's grace, in the next class, we are not going to discuss measurement, um, measurement and the tools or instruments used in measuring quantities in physics. So thank you very much for your time. We are going to meet in the next class.